The reduction of the nitroalkane molecules under acidic conditions using zinc and hydrochloric acid results in the generation of corresponding aliphatic amine molecules. If I want to give an overview of this reaction, I can say where on one side the zinc, being a metal and electropositive in nature, gives electrons. On the other side, the hydrochloric acid, being an acid, gives what? Gives the H positive ions or the protons. And it is this unique combination of the electrons and the protons that will actually help in the reduction of the nitroalkane molecule into a molecule of aliphatic amine. So now let us have a quick look on the mechanism of this reaction, and let us see how these electrons and protons will finally result in the reduction of the nitroalkane molecule. So you can see here it is a general Lewis structure of a nitroalkane, in which the R is what? It is some aliphatic thing here. And if you remember, in my very first lecture on this series of nitro compounds, I have discussed that how we can calculate the formal charge on any atom. It is given by the number of valence electrons for the free atom, the number of valence electrons for the free atom, minus the number of valence electrons for the bonded atom. So if I want to calculate the formal charge on this nitrogen, double bonded oxygen, and this single bonded oxygen atom, I can simply write here the formal charge for the nitrogen atom will be given by what? The number of valence electrons in the free nitrogen atom is what? It is 5, minus the number of valence electrons in the bonded nitrogen atom means what? Because we know each bond here is made up of the sharing of electrons, so I can show the electrons like this here. Even this bond here is made up of 2 electrons, such that this nitrogen atom here in the bonded state, it is now having a total of 4 valence electrons. You can count from here 1, 2, 3 and 4, such that I can write here number 4, and it will give me a formal charge of +1. So that if I once again draw the Lewis structure of this nitroalkane, I need to put a +1 of formal charge on this nitrogen atom. Drawing these electron pairs as it is, this oxygen atom contains 2 electron pairs, and this one here contains 1, 2 and 3. And now let us quickly calculate the formal charge on this single bonded oxygen atom. Let me write here which is bonded by a single bond. So this will be what? It will be the number of valence electrons on the free oxygen atom, which is 6 in number, minus the number of valence electrons on the bonded oxygen atom, because we are about to calculate for the single bonded oxygen atom. So the number of valence electrons will be what? It will be 1, 2, 3, 4, 5, 6 and 7 here. So that I can write here number 7, and it will give me a formal charge of -1, such that I need to put a negative sign here on this oxygen atom. And finally the formal charge for the oxygen atom, but this time for this oxygen atom here, which is bonded to the nitrogen atom by a double bond. This will be given by 6 minus, in this case, the number of valence electrons around this oxygen atom are 1, 2, 3, 4, 5 and 6. And 6 minus 6 will give me a formal charge of 0. So there is no need to put any charge over this double bonded oxygen atom because it contains 0 formal charge. So finally now we are having a situation in which this nitrogen atom here is having a positive charge and this oxygen atom here is having a negative formal charge. So now let us start with the mechanism of this reaction. On this arrow here, the first thing which I will put is the proton which is coming from the hydrochloric acid. And now what is going to happen is this oxygen here is having a negative charge. This H here is having a positive charge. And because the opposite charges attract each other, so definitely this oxygen negative will be going to attract the H positive ion, resulting in the formation of a bond with this H, so that this O negative will finally become what? A hydroxyl group here. And this double bonded oxygen atom will be present as it is. It contains 1, 2, 3, 4 electrons in the form of 2 electron pairs, and this is not having any electron pair, it is having a +1 of formal charge. On the other hand, out of these 3 lone pairs, let us say any one lone pair has been utilized for the formation of a bond with this H positive ion, such that now this oxygen atom will be having just 2 lone pair of electrons, which can be shown like this. And after that, an important step is about to happen, and that is known as the single electron transfer. A single electron will be transferred from the zinc metal, and we can show it like this. This will be transferred to this oxygen atom, and these electrons will be shifted to the nitrogen atom, finally resulting in the formation of our single bond nitrogen. After the shifting of these 2 pi electrons onto this nitrogen atom, what will happen? This will become a single bond. The oxygen atom as it is, the single bond hydroxyl group as it is here, and let me show here the lone pair. This contains 2 lone pair of electrons, this contains the 2 lone pair of electrons, but also the single electron need to be shown here, which is coming from the metal itself. And moreover, this nitrogen now will be having a lone pair of electrons, such that the formal charge will now be what? It will be 0, and there is no need to put any positive or a negative charge here over this nitrogen atom, because the number of valence electrons in the free nitrogen atom are 5, and here in the bonded state it is having 1, 2, 3, 4 and 5 valence electrons, which will be giving me a formal charge of 0. And even in this oxygen atom, the formal charge will be what? It will be 6 minus the number of valence electrons for this bonded oxygen atom are how many? 1, 2, 3, 4, 5, and this 1 electron from this sigma bond here. So it also contains 6 valence electrons in the bonded state as well as in the free state, which is giving me a 0 formal charge. So after that, what will happen is a second single electron transfer will be going to take place. I mean, a single electron will be transferred once again to this oxygen atom like this, resulting in the formation of our single bond nitrogen, single bond oxygen here, single bond oxygen having a hydrogen atom. And the lone pairs can be shown like this. This also contain a lone pair of electron. This also contain the first lone pair, the second lone pair, as well as when the second electron came from the single electron transfer mechanism, this will become what? This will become a lone pair here. And when you people will try to calculate the formal charge on this oxygen atom, you will see it will be having a -1 of formal charge. After that, because this oxygen atom here is having a negative charge, it will react with the H positive ions coming from the acid, resulting in the formation of our single bond N, single bond oxygen here, single bond oxygen having hydrogen atom. This is having a lone pair of electrons. This is also having 2 lone pair of electrons like this. So out of these 3 lone pairs, because 1 lone pair has been utilized in the formation of a single bond with this hydrogen atom having a positive charge, so now it will be left with what? It will be left with 2 lone pair of electron, the first one and the second one. Now after that, it will once again react with the H positive ion, and it will be going to the oxygen atom of one of these hydroxyl groups, resulting in the generation of our N, single bond OH here, single bond OH here, and when this H positive will go to this oxygen atom, let us say on this hydroxyl group, it will now be having a positive charge. Now the beauty here is what? This thing here, it can act as a very good leaving group, because oxygen here is having a positive charge, and being an electronegative type of element, it is not happy to have a positive charge. The best thing it can do is it can take its electrons like this, and it can just move out of the system in the form of a molecule of water. But how this is going to happen? The driving force behind this is what? These electrons from this oxygen lone pair, they will be shifted in between this nitrogen and the oxygen bond, releasing this OH and H in the form of a molecule of water, such that I can now show here minus water. Here I can draw R, single bond nitrogen. This will now become a double bond oxygen here, hydrogen here on this side, because it is giving 2 electrons. So definitely now it will be having one lone pair and a positive charge here on this oxygen atom. This nitrogen here is having these 2 electrons, and because this is going out of the system, so we will not be showing anything here on this side. And after this, it will lose a proton from here, minus H positive, resulting in R, single bond N. This is having a lone pair here, double bond oxygen here. This is having first lone pair, and because H positive is going out from here, so both the electrons will be coming to this oxygen atom, and it can be shown like this. So now for this nitrogen atom, the formal charge is what? The number of valence electrons in the free atom minus the number of valence electrons in the bonded atom, and they are how many? 1, 2, 3, 4 and 5, which is giving us a 0 formal charge. So no charge is to be put here on this nitrogen atom. In the same way, for this double bonded oxygen atom, the formal charge will be what? The number of valence electrons in the free oxygen atom, which means 6, minus the number of valence electrons in the bonded oxygen atom, 1, 2, 3, 4, 5 and 6. Once again a 0 formal charge here. And this is an important intermediate of this reaction, and it is known as the nitroso compound. Let me write here nitroso. Now after this reaction has arrived at the nitroso stage, what is going to happen is it will once again react with the H positive ions from the acid, resulting in R, single bond nitrogen here, double bond oxygen. One of the lone pair has been utilized in the formation of a bond. This is having its lone pair as usual, and because one lone pair has been utilized, so this is having just single lone pair. Moreover, a positive charge has to be put over this oxygen atom in the form of a formal charge. And after that, the set mechanism will be going to take place, and a single electron here from the zinc metal will be transferred to this nitrogen atom, sending these electrons onto the oxygen atom, resulting in the generation of R, single bond nitrogen. This will now become a single bond oxygen having a hydrogen. This is having a lone pair, and when this pi bond will be going to this oxygen atom, this will become a second lone pair here. This as usual is having a lone pair of electrons, and now it is also having this single electron which is coming from the zinc metal. And after that, the second single electron transfer mechanism will take place. This electron will once again be transferred to this nitrogen atom, resulting in R, single bond nitrogen, single bond OH here. This is having first lone pair, second lone pair. This is having first lone pair, and now when this single electron will be going to this nitrogen having this odd electron, this will also become a lone pair of electron, such that this nitrogen atom here will be having a formal charge of 5 minus 1, 2, 3, 4, 5 and 6, which is giving us a -1 of formal charge. So it is important to put here a negative sign like this, which after reaction with a proton will result in R single bond nitrogen here, single bond OH, and the reaction of this H positive with this nitrogen negative will give us what? H here like this. And because one of the electron pairs out of these two has been utilized in the formation of a bond with this H positive, so it is now left with a single lone pair. And this oxygen atom here is as usual having two lone pair of electrons like this. And this will give me my second intermediate of this reaction, and it is known as the hydroxyamine. The reaction won't stop here. And finally, this hydroxyamine will also be reduced in the same manner, giving rise to the corresponding aliphatic amine molecule. This hydroxyamine will further react with the H positive ions that are coming from the acid, and it will be going to this oxygen atom because it is having these lone pair of electrons, resulting in the formation of R single bond nitrogen, single bond hydrogen here, single bond oxygen H. And when one of the lone pair has been utilized in the formation of a bond with this H positive, what will happen is I can show here a single bond and a hydrogen atom. And now it will be left with a single electron pair, and this is also having its lone pair like this. The formal charge on this oxygen atom will be +1. Also we can say it is having 3 bonds here, so it will be having a +1 of formal charge. We can also show here by using that formula the number of valence electrons in the free oxygen atom means 6 minus the number of valence electrons in the bonded atom 1, 2, 3, 4 and 5, giving a +1 of formal charge, which you can see here. This can act as a very good leaving group because oxygen here is having a positive charge. Being an electronegative element, it is not good to have a positive charge on this oxygen atom. So what it can do is it can take these 2 electrons of this single sigma bond towards itself like this, resulting in the elimination of a molecule of water from here. And now we will be left with this R group, single bond nitrogen, single bond hydrogen here. This is having a lone pair of electrons like this. And moreover, the formal charge here on this nitrogen atom will be what? It will be 5 minus 1, 2, 3 and 4, giving me a +1 of formal charge. So let me write here a plus formal charge on this nitrogen atom. And now the single electron transfer mechanism will operate, and this single electron will be transferred to this nitrogen atom, resulting in the generation of R single bond NH here, this lone pair as it is. And when the single electron will go to this nitrogen atom, the situation will be something like this. And this will now be having a 0 formal charge because the number of valence electrons in the free atom are 5 minus in the bonded atom 1, 2, 3, 4th and 5th here, means 5 minus 5 equals to 0. And finally, the last single electron transfer mechanism will operate, and this single electron will be transferred once again to this nitrogen atom, resulting in the generation of R single bond NH here, the first lone pair. And this will now become, after the single electron transfer, this will also become a lone pair of electron like this, giving a formal charge of -1 on this nitrogen atom, which can be confirmed by the formula 5 minus 1, 2, 3, 4, 5th and 6th from here. So this will give me a -1 of formal charge. So the last step is what? It is the reaction with a proton from the acid, and this will be going to the nitrogen negative, resulting in the formation of RNH, and this will be utilized in the formation of a bond with this H positive ion, such that I will be having H here, and now it will be left with only a single electron pair. And this is what it is a molecule of aliphatic amine. We can say the zinc metal donate electrons. On the other hand, the hydrochloric acid donate protons, and it is this combination that is actually helping in the reduction of the nitroalkane into amine molecule. Hope you have liked this lecture. Thank you so much.